All right, so I want to get back into doing some more layout stuff. So there's a lot going on right here, but I'm going to explain it all to you. So we're going to talk about a roll inside of a flange, okay? When you have an offset like this, right? A roll. So you have a pipe going this way, the pipe's going to turn up here, and it's got to hit a flange, okay? Now this line just represents this flange being two-holed, which just means it's level, all right? So if you were just to make this piece and then you have your 90 and then a flange and you just two-hole it to this pipe, when you go to bolt it up, it's not going to fit. It's going to have a roll to it because of this right here, okay? So how we get this right here is in my previous video that I've shown you guys before, I'll put it up on screen. It's basically the same as doing a parallel offset in a sense, okay? So what you're gonna do is you're gonna have your pipe running this way and you have a flange up here. Well, obviously you have to figure out this right here, right? Because this is gonna be what's important. It's gonna get you your distance from center to center. So say you drop a string down and then you drop a string this way, or you just tape measure over, okay? That's pretty important. That's pretty common in a lot of things whenever you guys have elevation changes and stuff, right? So in this case, I got 10 inches from center to center, okay? And then I got a difference of 11.5 inches. Now I gotta find the hypotenuse, which the hypotenuse is gonna be, your run, how long your run's gonna be. Without cutbacks, this is gonna be your center to center, okay? And as I said before, you just use the Pythagorean theorem, which is how I usually do it, okay? So it's gonna be one side squared, one side squared. So it's gonna be one side, so it'll be 10 squared plus 11.5 squared is gonna equal 232.25, okay? And then you're gonna square root it, which is gonna give you 15.23. So that's what I have right here, 15.23, okay? So that's gonna be in inches. It's gonna be my center to center without cutbacks. Obviously you're gonna do your cutbacks, but we're talking about the roll on this flange right here. So that's how you get that. But this is important to get your degree. So once you have this right here and you have this right here, like I talked about in my previous video, which I'll also put on screen, you guys can go check that out too if you guys need some more detail. We're basically gonna figure out what this degree is. And how we figure it out is we're gonna do 11.5 divided by 15.23, okay? So it's gonna be side divided by your hypotenuse. It's gonna give you 0.755, and it's gonna give you more numbers, but I'll explain right now. So it's gonna be 0.755, okay? Then you're gonna hit equals, and then you're gonna hit second cosine, which is gonna put the cosine in the negative, okay? And then you're gonna hit equals and it's gonna give you a number. In this case, it gave me 40.97. Now on my calculator, I left all these extra numbers in here and then hit second cosine, which gave me 40.96, okay? It's not that big of a difference. You know, you're talking about a tenth, right? Not too bad. So once we figure out this degree here, now you know how much this is gonna roll up, okay? So now you know how much to roll this right here. So now you know whenever you go to fit this piece, you have to roll it 40.96 degrees off of square, so that way you can hit this two hole. So basically when you're down here and you bring it up, so you already have this rolled at 40.96 degrees, when you roll this up, it's gonna hit your two hole. So that's basically how you would find the roll on this. Now say for instance, this two hole's not two holed. Say it's 4 degrees out one way or the other. That's okay. You still need this number, and then depending on if it's rolled this way or rolled that way, you either add or subtract to this and you'll still be able to hit your mark, all right? So my next video, I'm gonna show you guys how to fit this up in the rollout wheel and how it looks. That way you guys can probably, hopefully get a better visual. But this is basically how you would find the roll on a flange when you're doing an offset like this, okay? And if you guys go check out my other videos, you guys can put my videos together and it'll help you with other problems. So if you guys have seen my how to find the degree on a parallel offset, it's basically that. It's just up on the wall. It's going to be really similar, okay? This will also convert when you guys are trying to figure out a rolling offset with the flange. So say you come out here and you have to shoot this way and shoot this way. This is just the missing triangle that you guys would need to get your roll whenever you guys fit another piece. I'll make a video on that as well, but I just wanted to show you guys this right here. If you guys have any questions or comments, feel free to leave them. Send me a DM if you guys want. If you guys want some more detail, let me know. I'm more than willing to help. So hopefully this helps somebody out there. If you guys have any questions, just let me know. Thank you.